So friends, in this video, we will look at the function that represents the transverse wave. And as you can see here on the screen, this is the function that represents a transverse wave. And we use the sine function over here, and that's why it is also called a sinusoidal wave. So let us try to understand the significance of each parameter in this particular wave. And it is very important to solve the problems related to the transverse wave. You need to understand each and every parameter. So as you can see, this transverse wave is a function which depends upon x and t. So if you want to find the y, you will need two parameters, x and t. Okay, generally how this wave looks like is this one. Now let us try to find out the significance of each of these parameters. So first with the starting with the first letter A. So A stands for amplitude and it is given by the peak value of the particle. So you can see that here the peak value is at this point, right? So that is the amplitude. So if you are given a function like this, you can easily find out the amplitude. Whatever is right in front of the sine function, it is an amplitude. For example, let us say this is one of the function of the sine wave. So based upon this, you can find out that amplitude is 2 in this particular case. Next one is k, right? So k is basically a 2 pi divided by lambda, and it is also called as wave number. And it depends upon this lambda, that is the wavelength. So wavelength is basically the distance between two troughs or two crests. So distance between two crests, that is called as lambda, and that is fixed for any transverse wave. So if you know the wavelength, you can easily find out the value of k. The next thing is x. What is this x? So basically x is the position of the particle along the x-axis. So particle can be anywhere, right, on this x-axis. So if you want to find out exact position of the particle on the x-axis, you can use this x. So in this particular equation, x is equal to 2. Okay. Then next one is omega. So omega is the angular velocity of the wave. A typical transverse wave has specific angular velocity. You can get it from this particular function itself. Then t is the time. So if you consider any particle, it is doing simple harmonic motion along the y-axis. So it will go up, then come down, again it will go up, come down. So that simple harmonic motion is happening continuously. And that's why any particle, if you know the x position, you can't determine the y position because it depends upon the time. The same particle at different times can take different positions along the y-axis. So let us say at t is equal to say 1, the particle is right over here. Say after 2 seconds, let us say it is over here. Okay, so even if the x position is fixed for that particle, y position is dependent on the time, right? And that's why this function depends upon x as well as t. For any given particle, if you know x and the time, you can determine its y position very easily using this particular function. And finally, phi. The phi is a phase constant. Okay, so basically that tells the phase shift in the wave. So the same wave can be represented in different ways. For example, this wave can be represented like this one. So here you can see that at x equal to 0, when the phase constant was 0, the y coordinate was right over here. But since we have shifted the wave by say 90 degrees, the y coordinate is showing as over here, which is equal to a. And that is what the phase constant is all about. It just tells you when you started measuring the wave, at what point or at what phase. That's it. Thanks for watching.